All right, this is to give you solutions to review for the solutions quiz, so solutions for solutions, think of it that way. When you go to find ion concentration, remember we always do molarity times liters to get moles. So if you notice here, I have a molarity of 1 for this right here, so I pop in 1 here. Notice I have 300 milliliters. I'm going to change that to 0.3 liters. When we're dealing with ions, we have to pay attention to subscripts. If you notice the K right there has a subscript of 1, but we're really targeting the number of ions. What we're trying to do is count the number of ions. So 1 times 1 times 0.3 would give us 0.3 moles, 0.300 moles of K plus. Then if I go and take the second one, well, the first thing is my molarity is 2, so I go 2.0 right there. My volume is 0.700, so I drop it in there. And last but not least, my number of ions is 3. So I have to put a 3 there. So 3 times 2 is 6 times 7 is going to be 4.2 moles of K plus. So then ultimately I added the moles together. I have a total number of moles of 4.5 moles of K plus. My new volume is 300 plus 700. So I have 1 liter, which means my molarity would be 4.5 molar. Be aware of the subscript of ions. Next. Which of the following is a strong electrolyte? Remember, strong electrolyte, there's 3 kinds of strong electrolytes: strong acids, strong bases, and ionic compounds. So when I go over here, I classify this. This is a weak acid. This is an ionic compound, so therefore that is the correct answer. This is a trick. That's an alcohol. It's actually a non-electrolyte. COOH is a weak acid, so therefore it's a weak electrolyte. And NH3 is a weak base, so that means that is a weak electrolyte as well. So the strong electrolyte in there means it produces the most ions. It's going to be the ionic compound. Next, how do you prepare a solution in chemistry? Well, the equation we use is M times MM times L, and that gives us grams of solute in chemistry. So then what we do is we take the numbers we're given. We get 3 liters, so I put 3 liters right there. And I take 0.2 as my molarity, and molar mass is 212. By multiplying these all together, I get grams of solute. Now, it might be easier for some people to just put this in scientific notation. I don't know. You can just do the math if you want to, or I would just do this. I would go 2.0 times 10 to the negative first. Change that into scientific notation. This is going to be 2.1 times 10 to the second, and this is 3.0 times 10 to the 0. So all I do is I take 2 times 2 times 3, I mean totally rounding, but what? 2 times 2 is 4 times 3 is 12. Then I just add all the exponents. 0 plus 2 is 2. 2 plus the negative 1 is a positive 1. So then I'm going to get that, which is the same thing as saying if you move it back over 120. So I know that I need 120, roughly 120 grams of solute. So it can't be this answer, it can't be that answer, it can't be that answer. So it comes down to either C or D. Why is C the correct answer? Because when we make a solution, we take a volumetric flask, and what you do is you add the solute particles. So we'd weigh out about 120, well, 130 grams solute particles go in there. And then what we do, the solute particles take space in the solution. That's why a volumetric flask has a specific marking. You add water until you get the mark in the flask. You hit that little mark, and then you shake and you make your solution. So that's why C is the correct answer, because you have to add sufficient water to obtain the final volume. That's why we use volumetric flasks to prepare solutions. Here's almost the same type of calculation. Molarity times molar mass times liters will get you grams of solute in this case. So if I look right here, MgSO4, molar mass is 120. Liters, I have 0.1 liters, and then finally 5. Well, 12 times 0.1, or 120 times 0.1 is going to be 12, because anytime you multiply times 0.1, you basically move the decimal over to the left. So 12 times 5, roughly, is going to be 60. Easy, quick calculation. Next one. How many milliliters of concentrated nitric acid, 16 molar, are needed to prepare a 0.5 molar solution? So remember, M1 V1 is equal to M2 V2, right? So when we go to do this, I pop in 16.0 is my original molarity of my stock. This is stock solution. This is dilute. And then I'm producing 6.0 of a 0.5 liter solution. So I set that up like that, and then I basically have to solve for V1. So basically what I do is I'm going to put the 16 down here. Basically, if I look here, half of 6 is 3, so 3 over 16. 4 over 16 I know is 0.25. So basically it has to be a little less. Since it's not 4/16, it's 3/16. I have to know that it's got to be D 190 based on that, just because of the ratio. So you could do the math and work it out. That's just my way of quick solving it. Which of the following aqueous solutions would have the greatest conductivity? Conductivity is related to the number of ions you have. More ions, the greater conductivity. So if you look here, this breaks into 2 ions, this breaks into 2 ions, that breaks into 2 ions, that barely breaks apart because it's a weak acid. This breaks into 4 ions, thus that has the greatest electric conductivity. How many milliliters of water must be added to 50 milliliters of 10 HNO3 to prepare 4.0 milliliters of HNO3? So if you look right here, when I go to set it up, this is my M1, so my molarity is 10 basically. My milliliters I start with of stock is 50 milliliters equals 4 is the new molarity I want, and X. Well, 10 times 50 is going to be 500, divided by 4 will equal my X. When I go and solve for this, I get 125 is the amount of my total volume. But I already had 50 to start with. So if I have 50, I need to bring my total volume to 125. I'm only adding 75 milliliters. Be aware of the idea of added. They use that pretty frequently. That's why E is the correct answer. So if you see added, it means you have to go back and do a little subtraction there. Best method to isolate pure MgSO4, if we put it in solution, it breaks up into Mg2 plus, SO4 2 minus, right? The only way you're going to get those ions back together, filtering, they're basically dissolved in solution, doesn't work. Really what you're going to do is if you evaporate it, the salt will reform. So when you go to get a soluble ionic compound in solution like salt, if you want to get salt out of salt water, you could evaporate the water and you would be left with the salt. Ksp, molar solubility. Remember we did Ksp, like for example MnOH parentheses 2 would break into Mn2 plus 2OH minus. Remember the ratio. We do a mice table, so when you go to do a mini ice table, this is plus S and this is plus 2S. What they do in these problems is always driven by the ratio on the E line. They'll give you one or the other. Now in this case, they're telling you what the Ksp is. They're telling me what the Ksp is, so what I do is I just have to drop this into the equation, my expression. Ksp is Mn is to the first, OH is to the second. So I write the expression separate from the ice table. They're different to make sure I get the ratios right. I do this, so I have this. So then basically, when I drop 2s in here, this is 2s squared, and this is s. Ultimately, I know that Ksp is equal to 4s cubed is equal to Ksp. So then basically when I go and do my calculations, so ultimately I basically have 4s cubed is equal to 1.6 times 10 to the negative 13. So remember, we like to do everything in scientific notation, so like it makes it easier. So in order to get rid of the 4, I basically divide by 4.0 times 10 to the 0. It's the same thing. 1.6 divided by 4 is going to be 0.4. 13, remember numbers in scientific notation, when you divide, you subtract. So negative 13 minus a 0 is going to be 10 to the negative 13th. This is not a proper scientific notation though, so moving it that way gives me 4.0 or 4 times 10 to the negative 14th. How do I get rid of the cube? I take the cube root of it. So ultimately, A will be your correct answer based on the math. You have to do the math in scientific notation. Next one, which of the following expressions will be equal to the Ksp for this? If I take Ag2CO3 and I drop it in water, I'm going to get 2Ag plus CO3 2 minus. My little mini ice table on my ratio, this is 2S and this is S. Be aware of the ion concentration. So if they gave you silver, it would be double of what carbonate is. If they gave you carbonate, it would be half, and you would have to double it to get silver. In this case, they just want the expression. So then it would be Ag plus to the second, CO3 to the first. C would be the correct answer for the expression, but keep in mind, though, they will always give you one of these ions, and the ratio won't match, and they'll have you solve using one of those. Solubility of BF2 is equal to X, which of the following expressions is equal. So if I go BAF2 is going to break into BA2 plus 2F minus. If I go to write the expression, I say Ksp is equal to the concentration of BA2 plus times the concentration of F minus squared. This is S and 2S. So when I drop these in, ultimately, when I solve it, it's 3 ions. It's going to be equal to 4S or X cubed. Remember the ratios. The ratio here is different from the ratio here. Write the expression and keep the ice table separate. Solubility of strontium fluoride in water. So they're telling you that's the solubility. What's the value of the solubility product? Here's an example. If I have strontium fluoride is SrF2. So that's going to break into SR2 plus and 2F minus. It is a 2-to-1 ratio. When they're telling you the solubility, they're telling you S. So this is 1.0 times 10 to the negative third. This, pay attention to the subscript, is double, so I go 2.0 times 10 to the negative third. I do that first, then I go to my Ksp expression. This is going to, SR is going to be to the first, F minus, so this would be SR2 plus to the first, F minus to the second. So ultimately what I have to do to solve is I take this and I take this. This has to be squared. So when I square this, 2 times 2 would be, when you go to square this, erase this out of the way, do this, 2 times 2 is going to be 4.0, and then what I'm going to do is 2 times, you just multiply the exponent in this case, so 2 times negative 3 is going to be 4.0 times 10 to the negative 6. I got that. Then 1.0 times 10 to the negative third, I'm going to multiply that. These numbers, 1 times 4 is going to be 4, and then I just add the exponents, so it's going to be 4.0 times 10 to the negative 9th. I take the negative third, negative 6, boom shakalaka. That's how I get Ksp. These are designed to be done in scientific notation even without a calculator. Solubility of this. So there's the solubility. First thing I look at is the ions. It's PBS. So what's that going to break into? PB2 plus S2 minus. So it's basically S and S. So then when they tell me the solubility of that, they're basically telling me S is 3.0 times 10 to the negative 14th. So then I basically am just going to square that. So when I go to square it, this is going to be 6, and then this is going to be times 10 to the negative 28. So I go over here, 6.0, what did I do wrong? Oh, whoops. 3.0 squared. Nice job, Davis. Maybe I should learn math. 9.0 times 10 to the negative 28. Whoops, daisy. All right, 3 times 3 is 9. Huh? Yeah, whatever. Anyway. Next, silver hydroxide will be least soluble. Remember when we talked least soluble? So it's AgOH, silver hydroxide. What's going to happen is it's going to break into Ag plus OH minus. So then what happens is common ion is when you reduce solubility. When they ask you least solubility, you're looking for most ion on this side. Well, in the case of OH, the higher the pH, the greater the OH concentration. So in this case, it's a gigantic Lechat. If I add a whole bunch of OH, if I have a super high pH, it shoves the reaction this way, which reduces its solubility. That's why that is the correct answer. Here's another example. It's asking me least soluble, copper chloride. So I go Cu, it doesn't say what copper chloride is. We'll just say CuCl2, whatever. Cu2 plus 2Cl minus. If I look here, they're all the same molarity. I get 1 chlorine out of there, 1 copper out of there, 2 chlorines out of there, nothing there. I have no common ion there and no common ion there. So C is the correct answer. Why? The more common ion I add, the greater the ion concentration, the greater the Lechat. So that's going to shove me over and reduce the solubility. All right, this is an example of gravimetrical analysis. You have to use stoichiometry of a precipitate. When we go to do this, we find out using solubility rules, we know Br and Ag produce precipitate. So if I want to get basically rid of all the Br as AgBr, I would take Ag plus, add some in there with the Br minus, and ultimately I'm going to get AgBr as a solid. So that's my reaction. It's different than the KSP because this is gravimetrical analysis. You're adding something to precipitate out an ion is what you're doing. What do we need? We need moles because this is basically stoichiometry. They tell me I have 1.0 moles of Br and 2.0 moles of BaBr2, which means when I go to get my total number of moles, you got to make sure you use the 2 and double it. So ultimately I have 0.5 moles of Br. Why? This is equal to 0.1 because of the subscript there. I'm actually going to get 0.4 out of that. So I have 0.5 total. So how much would I have to add? How much silver would I have to add? I would have to add 0.5 moles of silver. To precipitate out, I would get 0.50 moles of AgBr as a solid. That's an example of gravimetrical analysis. When they're trying to precipitate something out, that's gravimetrical analysis. So what your focus should be is you should make sure that you go through and do the calculations, change to moles, start with the reaction, pop it in, and then you can see. You can also calculate leftover ions. So for example, let's say I only added 0.4 Ag. Well, my limiting reactant is going to be 0.4, so this would be 0. This would be 0.5 minus 0.4. I would have 0.1 of this left over. So I could figure out what the new ion concentration would be based on the volume. That way, that's another example of gravimetrical analysis. Okay? This should have gone through all the key questions that you saw on that sheet. Should have been able for you. I would go back and make sure you know your electrochemistry and go through your objectives and make sure you have all your objectives. Have a good evening, you guys. Almost done.